Well, before we prove L'Hopital's rule, I want to show one other way that we could have found this limit without using L'Hopital's rule. But make a note that it is not always the case that you're able to do it without L'Hopital's rule. L'Hopital's rule will save you great deals of time, and actually it might be the only way to find the limit as x goes to x naught of f of x over g of x. But this one could have a little bit more of an algebraic kind of proof, just by noticing that x minus 1 over radical x squared plus 3 minus 2 is equal to, well, what I'm going to do is rationalize the denominator. I'm going to take the bottom and the top and multiply it by 1 in the form of the conjugate of this, which would be radical x squared plus 3 plus 2. So I have to do it on top and bottom. So effectively we're multiplying this by 1, so we get an equivalent expression. And on the bottom, what we're going to get essentially is, when you FOIL it out, the inner and outer are going to cancel out, and we would simply get the first squared plus the second squared. So the first squared is, just remove the radical. It's x squared plus 3. And then I said plus the last squared. We'll multiply the last times the last. We get a negative 4. So I will, I'll go ahead and put the minus 4 there. So we've rationalized the denominator, and that makes the top, I guess I have to FOIL that out. So we would get x times radical x squared plus 3 plus 2x. That's what I get. Those two terms come from x times this plus x times 2. And then I've got to do a minus radical x squared plus 3. And then the last would give me a minus 2. So let's see how we can simplify the top. We get x squared minus 1 on the bottom. And actually, this was pointless. I didn't need to FOIL that out. Let's just keep it x minus 1 times radical x squared plus 3 plus 2. That's the numerator now. The reason is, we'll see in a sec, is that x squared in the denominator is the difference of two perfect squares. It's x minus 1 times x plus 1. I'll just write it that way. Minus 1, x plus 1. So now the x minus 1's cancel out, and we get x squared plus 3 plus 2 over x plus 1. And now the limit of the top, as it approaches 1, would be 1 plus 3 is 4, 2 plus 2 is 4. On the bottom, as x approaches 1, we get 2. And of course, we get the same answer. The limit is 2. And in the next video, we'll do the proof.